You're looking in my Emacs editor at another working file. This is called servletoverview.txt. It summarizes the code modules that are at work in this revision of the predictions web service. So again, this is a REST-style web service. It differs from the original in that it supports all of the CRUD operations, and it also can return either XML or optionally JSON responses. So we'll get into those details when we look at the appropriate code. What I'd like to do now is just quickly go through the three main source modules and then focus a little bit on one of them. So the first is prediction.java. This is a standard Java bean. It's got three properties: who, what, and ID. We'll look at that code momentarily. I'm going to jump over the middle one for now and jump down to predictions servlet.java. This is the servlet that implements the CRUD operations by defining do post, create, do get, read, do put, update, and do delete, which is delete. As noted, this version of the prediction service can return XML, that's the default, or JSON upon request. Now let me focus a little bit on the middle module, which is basically a utility class. So it contains some properties, but the main thing we care about are two fields. It has a concurrent map, so it has a map of all of the predictions. The key for a lookup is the prediction ID, and the value is the full prediction, who said what. There's also an atomic integer, which provides the keys. So the keys are unique numeric values, very much akin to what you would see in a database. Both of these classes, very important, come from java.util.concurrent and its subpackages. Technically, concurrent map, by the way, is an interface. The implementation I'm using is the concurrent hash map. So the question basically is why. So consider this situation. Suppose we have two clients that hit the service at the same time. One of them wants to update prediction 32. The other one wants to delete that same prediction. Clearly, we can't let this happen. We have to have some coordination. So these two requests have to be serialized in some appropriate way. One has to come before the other. And for example, if the updater is at work, we can't let the deleter get at the prediction at all. Now let me put this in more technical terms. Java-based web servers, such as Tomcat and Jetty, implement what is sometimes called the one thread per request model. That is, as a request comes into the web server turns that request over to a thread taken out of a pre-built pool. The pool of threads is pre-built for efficiency reasons. That thread is then responsible for handling the request from start to finish. So what we have here then in this application is the classic thread synchronization problem in Java. There are many different ways it could be handled. I'm going to handle it in a fairly high-level way. The concurrent hash map and the atomic integer are both thread safe. So the thread synchronization is baked into those data types. So that's why I've picked them. There's one and only one concurrent map. It contains all the predictions. And basically, I'm letting the concurrent map implementation make sure that one client can't edit the same prediction that another client is deleting at the same time. Now, what I'd like to do is take a very brief look at prediction.java, the first of these Java beans, since it's the simplest piece of code, and then we'll go on to the other two modules. So let me bring up another working file. This is called servlet wscode1.txt. And as you can see up here, it's the prediction class slightly changed from the original implementation, and the change is here at the end. The class now implements the comparable interface, and the implementation is down here. There's a method called compareTo. This basically supports ascending sorts. So let me give you the bottom line. It'll be convenient to have the predictions always in sorted order So that, for example, if you add a new prediction, it'll be shown at the end of the list. If you delete a prediction, it'll be easy to spot where it should have been and no longer is. So I'm going to use sorting mostly to help with the testing. When we looked at the curl commands last time, if you run those again, you'll see that everything is always presented in sorted order by prediction ID. Beyond that, this version is pretty much the same as the previous one. That is, there are three properties. There's a who, that's who makes the prediction. You see that at line 2. There's a what at line 3. That's the prediction itself. And then there's the ID, which is the unique identifier, and also the lookup key basically for a given prediction.